So, hi everyone and welcome. And today I will show you an open source project that can revolutionize the IoT market. The project is aimed to fight fragmentation in the IoT industry, help companies in the development process, and even create new business opportunities. I'll go through the main problems that IoT is facing, how device maker companies can drive the change, and how developers will benefit from it. So let me introduce myself. I'm Ettore Chimenti. I'm an embedded Linux engineer at SECO, a global industrial IoT company and device maker. I'm currently managing the SECO hardware enablement in the Oniro project. And SECO has been working in the field for more than 30 years in the embedded industry, and it also involved in open source projects, and it also is an Eclipse partner. So let's start with the IoT fragmentation issue. In the last years, we are witnessing a large and exponential growth in IoT devices on the market, much higher than consumer electronics. Many companies are building smart solutions, adding connectivity, artificial intelligence, data telemetry, cloud services, and analytics to the product. So in 2025, we will top 9.27 million devices per person. So that's really a lot of devices going in the market. And development got a huge boost in the last years. And many open and proprietary solutions are rising, creating many digital ecosystems and new hardware devices. But all of this is raising a problem for both the customer experience and the management of such a fragmented ecosystem. So how can we solve this issue? And how does this affect the whole IoT market? So the first point is that too many devices to maintain actively is really hard for companies. So as a device maker company, this is exponentially time-consuming, with a matrix of different combinations of software to provide and maintain to our customers. And the fragmentation also leads to technology silos, because even if using open source and technology, the resulting devices will likely not cooperate with different vendor products due to lack of open standards on how things are discovered and shared in the IoT world. We need an orchestration. There is a need of an orchestration capable of guaranteeing vendor neutrality and openness. A single company cannot impose a standard. So to avoid vendor lock-ins and uneven decisions, we need some kind of orchestration. And lack of truly open source end-to-end solutions, because the technology is also fragmented. There is no easy open source solution to build a project from start to finish, from the application to a specific hardware. And the communication between devices is enabled by discrete apps that are connected to clouds. So devices, in order to communicate, need to reach cloud and exchange data from cloud to cloud and then back to the device, even if they're in the same room. And for all of these reasons, the rise of fragmentation in IoT is not sustainable. It reduces the customer experience, and services are totally cloud-based, even if the devices are in the same room, as I said. In the end, the devices are totally independent, dependent on their vendors in terms of security. So how we fix this problem? First of all, we need some common code base among players, among companies that will allow them to talk the same language. So having a common code base will speed up the process of development and of maintenance of the code base. And it is also difficult to have a main base that targets all IoT devices. Usually we use Linux on bigger edge devices. We use FreeRTOS for small devices, Zephyr, etc. So we have a lot of options viable, but no thing that can have a common code base for everyone. So it's difficult to have a main base that targets all IoT devices, big and small, although many of the protocols and communication are common. We need some way to standardize the workflow. Having a standardization would speed up the solution development together with customers or with your own project. And the communication needs to be at the edge between the devices if they are needed to communicate with each other. Because if we rely always on cloud, usually cloud solutions are proprietary, are closed. We cannot redeploy the same solution for ourselves if we buy a device or we give a device to a customer, even if they're industrial or either consumer. So long-lasting IoT solution cannot live on the shoulders of locked vendor infrastructure. I think the future is to communicate at the edge. And open collaboration between players. We need to open up to share our ideas, our standards to everyone when we are developing a solution. So, and to team up to build and share requirements for our customers. For example, we have a lot of devices for customers, and we need to use some kind of standards for talking to them and for every customer we have. And we need to exploit existing and consolidated technologies. We don't need to reinvent the wheel every time, because we should fill the gaps between existing technology, if there are any, and try to deliver to customers a full infrastructure. So, from all of these ideas, the Oniro project has born. A community open source project aiming to simplify and help developers to create secure, interoperable, and long-lasting IoT solutions. The project was launched in October 2021, exactly 1 year ago. Yesterday was the birthday of the Oniro project. And this has been possible thanks to a community of companies that team up under the umbrella of the Eclipse Foundation to give birth to this project. Eclipse Foundation, of course, as you know, ensures that the project is vendor neutral and open between the players without overwhelm each other. So what are the main principles of this project? The main idea is to have a common flexible code base. So for the development of an IoT solution that you're currently developing or will develop in the future. And it's targeting big and small IoT devices, supporting multiple kernels, like Linux or Zephyr. This approach widens the offer for industrial partners and can target multiple vertical businesses. So ranging from edge devices like edge gateways to infotainment to vending machines, or to smaller devices like door locks or small sensors that you can use at home or in an industrial environment, for example. One of the others main principle that we have is to reuse existing solution as an ecosystem. So being like a glue between all the existing technology that we are currently using. So it would be a waste to ignore and develop existing technology that are the standard and have a wide community. So we don't want to impose a new standard in terms of technologies, but we want to have the same place for the developers to come and develop their own project. So focusing on the application rather than redoing all the things again and again. This helps and speed up the development process. And last but not least, we want to use open standards and interoperability protocols to make sure that devices can last longer because of open standards. So we try to avoid the technology silos in this way. And if they're decided among players, they are the key to avoid them. And another thing that we want to achieve also production-ready code base, compliant with the certification standards and free from IP proprietary licenses. In this way, everybody can leverage this project for their needs. So let's go a little bit technical now. So many of you maybe know the Yocto project. How many of you do know what the Yocto project is? Raise the hand. Okay. So it is a wide community project and we want to leverage the bit-bake building infrastructure to build the Yocto project. So it's very common and it's very popular for the embedded systems. So we want to the developers that comes and use the Oniro project wants to come and be comfortable, and also it's powerful and flexible. So it makes the build process easy to compile and target different architectures, such as single board computers and microcontrollers using different kernels. We want to use Linux for the big and Zephyr for the small. Furthermore, being compatible with Yocto makes it easier to create and integrate BSPs for new hardware. So if you want to integrate your own single board computer, it's easy to do that. And it's interoperable. You can compile your project for one type of hardware, or you can just change a variable and use another. So you can start developing with a Raspberry Pi, for example, and then switch to an industrial single board computer, for example. And of course, it's easy to add new software components and configure the operating system that you want to create. And as an example of what we did on filling the gaps between existing technologies, let me introduce the OTA system. So it's over-the-air update. This is really important for IoT devices to be updated. This is required for security reasons. If a security issue comes up, we need to fix the issue and make our devices secure again. So how do we tackle that? We developed just the sys OTA part, that is a runtime updater wrapper. So it's basically the magenta items. We are using Eclipse Hawkbit as an update server. So we generate the update and we store it on the update server. And we take down the update, and the RAUC updates runtime updates our device. But all the magenta items are replaceable with the other kind of update systems. If you have your own update server, you can just swap the Hawkbit client with your preferred updater, and this architecture by design, it's really flexible to use what your company is already using right now. If it's using an enterprise update server, it's possible to use another one. So Oniro is giving some defaults that user can pick up to rapidly build real applications, but every piece is customizable and replaceable by design with your preferred choice. So another feature of the Oniro platform is to add this collaborative AI to expose the capabilities of the devices to everybody, every device on the edge. So we can use different capabilities of the device to create new interaction, new scenarios. This and it helps the communication between devices and open up to also new business opportunities, because we can have some companies have new applications based on a cloud of devices that they have. For example, a camera can detect people in an area, and we can have smart lights that lights up when people pass by, for example, and we can have some companies that can develop this type of solution and sell on top of the devices. And since if all the devices runs Oniro, we can have a second. Even if the devices have different vendors, we can use that anyway, because they can communicate with this protocol. Another aspect is the standards and compliance. So it is crucial to enforce all openness and that the project is usable by anyone, as I said before. So we follow strict IP standards like open chain, S.p.A, and reuse. And as security and interoperability are the core aspects of IoT, it's important to adopt compliance and open specifications. In this way, the project can be used in industrial context, resulting in a faster certification process. In this way, it can be like production ready for all the companies, for example. Another thing is that we are also building an infrastructure around the code base. So we added continuous integration and deployment with in GitLab. So the whole development process is structured with CI/CD infrastructure that you can pick and redeploy at your company infrastructure, for example, and it checks IP compliance, provide documentation, testing environment with and it tests the environment with the reference platform that we have, for example. The testing is done with Lava. We have some Lava laboratory with the testing devices to ensure that there are no regressions in the code, that it tests the OTA pipelines. And yeah, the repository is also open that you can take and reuse for your company, for example, for your project. Last but not least, we have IP and FOSS check. So we are using a custom infrastructure for checking the IP compliance of all the software that are we using for building the images, the reference images for the project. So it ensures that everyone is allowed to use for their own projects. So there are no blockers on the legal side. So I want to summarize a little bit what the Oniro project is offering and what you can leverage for your project. We are developing an open source software core that is maintained and kept up to date with stable components from Yocto, BSPs, layers, toolchains, core libraries, and Oniro frameworks. All of this is supported and backed by the processes developed by the Oniro community, such as CI/CD, testing, documentation, maintenance, IP compliance, OTA, security stuff. And on top, we have some default configurations that you can change for your needs and help you kickstart your project with out-of-the-box configurations, so, operating system management, and hardened security. And finally, your applications. Oniro helps developers and companies by focusing on the application rather than on building and maintaining the whole system. So you can pick up what we did, and on top, it stays your applications. So it will save time and will accelerate the time to market factor. So SECO is a device maker, as I said before, and IoT solution provider for many verticals. So we make these IoT devices. It is for at least industrial embedded computers for the industry. And to serve industrial customers' demands, we introduced 3 reference industrial hardware platforms in the Oniro ecosystem to speed up eventual customers that want to build a new project out of for the IoT industry. So we introduced very heterogeneous devices here. We have an Intel, we have an XP ARM device, and a cost-effective ROC chip with an STM inside that supports Zephyr, along with QEMU, so virtualized targets that you can build on your computer and you can try without the industrial hardware, as long as the Raspberry Pi and Arduino for just prototyping the solution. This helps to test code feature to real hardware via CI/CD, so it's production ready, enabling security features and trying out other specific feature of the Oniro project. But most importantly, they serve as a reference for new hardware for other partners that want to join the Oniro project. So they already know how to develop and support the new hardware when they want to start using the Oniro project. But they also serve for another aspect, that is blueprints. And what are blueprints? They are service design that you can follow to build your own application. For example, this is a vending machine blueprint that you can go to the website and download the code, and you can use that as a reference for how to build a vending machine project, for example. So in this way, it's easier for developer to know how to implement a certain feature, or for companies to pitch ideas for a real use case. So this is not a vending machine, a finished vending machine, but it has all the components that helps to build a real one. So it has the UI. We are using a graphical framework for using the framework, the graphical part, and then we have the control part that goes in a microcontroller, and they are communicating. So you can see how we implemented that, and you can follow or completely hack the blueprint for your own need. So, and lastly, I wanted to say what is the device maker perspective on Oniro. As an active IoT global company, this project over the past year is positively impacting our business. And as an involvement as an industrial partner, we can include the requirements, actively support reference hardware, and share knowledge among all the partners in the project. This helped us a lot to grow our knowledge, our know-how on how to build things, and we shared ideas to the other partners to grow. Another thing is we are first to offer production-grade community OS to the customers. So the Oniro OS has grown along this past year, and it's approaching the first release that will happen in the last quarter of this year. And we get to offer a certified production-grade OS for our reference boards. Existing services such as data orchestration and device management that are included in our enterprise cloud, that's called CLIA, can we run on top of Oniro to extend the value proposition, for example, for our products. And we can propose new business models to customers, because it's possible to enter new business models based on devices that communicate at the edge. Think of entering an ecosystem of IoT companies that use Oniro, and we can offer services that are built for Oniro, for example, that can interact with each other appliances, for example. So and what is the added value for all the others, for example, that wants to enter the Oniro project. We have a global ecosystem that is rooted in Europe. So we are from all around Europe, our developers and companies. You have a shared pool of expertise and know-how on the embedded solutions. We can have a shared go-to-market strategy, so we can act as one for releasing the project. We are proposing a unified set of configs, APIs, protocols for developers to develop their own solution. We can co-develop and deploy our solution together. If there is a problem, we can help out each other. And of course, there is a co-investment in the development. We have a shared cost in building this project. We are not alone. So the first release, as I said, is going out soon. So please check out the website and go to the documentation, find out more, go to the chat and start chatting with the developers and the engineers that are behind it. So thank you for the attention, and hope you like the speech and join the community. And if there are questions, we'll be happy to answer. Thank you so much.